I'm introduce some of our experience of deploying OPNFV on ARM platforms. So more specifically, I'm to introduce the Compass4NFV project. So use this tool to deploy OPNFV on ARM. The agenda first is OPNFV overview, then introduce our experience, share our experience of deploying OPNFV, and then I will introduce the Compass4NFV project architecture, focusing on bare metal provisioning and the virtual provisioning. Then I introduce the OPNFV CI/CD and the testings. Also, we will introduce our works to make Compass4NFV running smoothly on ARM platforms. First about us, so we are ARM CEOSS teams, Central Engineering Open Source Software. We focus on open source community enablement optimizations for ARM platforms. So focusing on the enterprise softwares, such as the OpenStack and big data or networking, like DBDK, all these server level softwares. So this is a project that for OPNFV, this is a project collaborating with networking and workloads teams. So the goal is to develop containerized network acceleration solutions and develop containerized VNF solutions. Also, we need to run OPNFV on ARM platforms, and also we will follow the community best practices. So first, OPNFV overview. So this is a very brief diagram of what is OPNFV. So actually, OPNFV is a community, is a open source software community. So the purpose of OPNFV is to leverage upstream open source softwares to construct a reference NFV platform. So what it means is that OPNFV itself doesn't, how to say this, is not focusing on developing the whole solutions by itself, but it is an integration project to integrate upstream open source projects to combine them and integrate them and to make deployable and maintainable and easier to testing and standard NFV platforms. So the major components is integration, deployment, and testing. So for this slides, I'm focusing on the deployment and the testing parts of OPNFV. First, I want to introduce some of our experiences of deploying OPNFV on ARM platforms. So this is kind of a frustrating experience, I have to say. So first, you can see 3 steps. At the very beginning, we are using Fuel Installer for deploying OPNFVs. But Fuel Installer, this is a very complicated software. It has a beautiful UI. You can deploy a very complex systems just by clicking your mouse. But the problem is that sometimes it will fail. But if it fails, you must have to debug all of the debugging of the Fuel Installer is very hard, especially on ARM platforms, because Fuel is first developed on x86. For ARM platforms, there are many failures, and you need to do many hard debuggings. So this is very time-consuming. Also, if something bad happens, you have to redeploy the whole system again. You must tear down the whole architecture and redeploy again. This is very time-consuming. If I remember correctly, it costs 6 hours to redeploy architecture on 4 servers. So this is very time-consuming system. So also Fuel is now discontinued by Urantis. So this is our first step. It works, but it is not very smoothly. Sometimes it's a painful experience. So second, we move to our own scripts based on Ansible-based scripts to deploy deploy OpenStack. Then above OpenStack, we use standard OpenStack projects like Ironic and other projects to spawn a Kubernetes cluster about this. So it works, and it's also because we designed it by ourselves, so it's easy to debug, and it works smoothly. But the problem is this is not this is an unofficial solution. It's designed by ourselves, so it's not a OPNFV community standard solutions. So this is a big problem. So we cannot integrate our installers, our deployment processes with the standard OPNFV community. So this is also a problem. So we then we turned to our third approaches, third tries. We are using Droid installer. Droid is a standard OPNFV installer. So this is officially supported. It is developed by Canonical. So in the back end, it uses Mars and Juju for bare metal and up-level Kubernetes deployment. But the problem is Droid only supports Ubuntu because it's a canonical software. So it doesn't support CentOS or other distros. So this is one problem. It is not distro neutral. And the second problem is Juju doesn't support Kubernetes on ARMs. So we want to contribute to Juju project, but this is not very smooth. So this is the third tries. We didn't think it's a very successful try. So combining all these three experience, so we first need a easy-to-work systems, and we need an official OPNFV community official solutions, and third we need a true open source project, so we can contribute and we can make it work by our combining the community forces. So now we turn to our fourth tries, the Compass4NFV. We turn to this project. This is also a community OPNFV community standard OPNFV installer. So this is an official supported installer. So this is a lightweight design. So it's also based on Ansible and scripts. So share scripts. So this is a lightweight design. It's easy to debug. So you can use command lines to check all the logs, and everything is just shoot here. If you found some bugs, you just check the logs and dig the details. It's easy for newcomers. So it doesn't support ARM, but the community welcomes the contributions. So we did much contributions to Compass4NFV project, and we make it work on ARM smoothly. And it supports both OpenStack and Kubernetes. So we are focusing on, for now, we are focusing on Kubernetes, deploy Kubernetes directly on bare metal. So this is a perfect fit for our requirement. Also, it's a containerized deployment. So the deployment procedure, the deployment components, also jump host can be run inside in Docker image, inside in containerized environment, so it's easy to maintain. Also, this is distro neutral. Also, this is very important. So it doesn't depend on some distros. You can deploy you can deploy any mainstream Linux distros. It's based on Ansible, and it has flexible configurations. Last line I gave an example of how to quickly spawn Kubernetes clusters in virtual machines just using one line of code. Actually, this is one line of code, but if you run this, it will cost more than 1 hour to finish. So this is actually not saying this is an easy task, just saying to deployment for such a heavy task, we can use just a single command line. Now is the Compass4NFV architectures. You can see here, this is the major components of the Compass4NFV jump host. This is a jump host. At the upper levels, the Compass stack is a container running all the API services. So you can use command line scripts, or you can use a web UI, just through the RESTful API to connect, to control the whole deployment processes and to inspect the results. And in the middle, there are two middle levels. Where RabbitMQ is a message queue, MySQL database. So this is store some information of the deployment process. And this is the two most important parts of the deployment. So for every deployment, actually there are two components. First is you will deploy the bare metal operating system to bare metal. So this is what the Compass cobbler does. It deploys the Ubuntu or CentOS or other Linux distros above bare metal servers. And above this, if after operating system is running, you can use Compass tasks. This is another Ansible-based project. It is to deploy Kubernetes or deploy OpenStack above the running OS, and above which we can develop our VNF virtual network functions. This is a deployment procedure. You can ignore the left side. You can just check this once. So I just the last slides, the Compass cobbler and the Compass tasks are two major components. So for Compass cobbler, this is a cobbler. A cobbler is upstream Linux installer. So Compass cobbler use this cobbler as the core component. And so it imports the Linux distro ISO images inside it. So through the so it's running inside a Docker, but it uses the host network, so it can access the network interface because of the jump host directly to deploy the operating systems. Use the PCIe TFTP. So this is the standard server deployment ways. And after this, also you can run the Compass tasks, Kubernetes Compass tasks. So this is based on the Kubernetes project. Kubernetes is also a community standard project to run, to deploy and run Kubernetes clusters. So this is a deployment project for Kubernetes. So this is the two steps to run Kubernetes clusters from a bare metal servers. So all this are already working on the ARC64 platforms. Now I give some brief intro of how to deploy a bare metal, on bare metal server. So this is basically two configuration files that you need to configure before. The only two files you need to configure before you deploy to deployment. The first is the host configurations. You can see host just to list the host information. So most important is the whole bare metal host. You use the BMC to access the power. So you need BMC IP address, username, password, and the MAC address. So the PXE services can match the MAC address to give him appropriate IP addresses. So this is the list of the host informations. And so this is list of the network informations. So for network, so there are at least two networks are required. First is the management. So this is for installations. You can list the IP addresses. So it's also related to PXE. So when PXE booting, you have to give him some dynamic addresses. So it can fetch the installation images and deploy the operating systems. And also, it's not listed here, the external addresses. So the nodes also need external addresses to access the internet. So this is the two basic addresses required by a Kubernetes cluster. So this is the control. You can see this is the control interface, or can say management interface. This is the public interface. Similarly, you can deploy on virtual machines. So, so the Compass also supports deploy virtual machines. This is very easy for debugging. So before you do an actual physical deployment, you can first try every environment inside a virtual environments. So you just all these virtual machines, VMs can be spawned inside the jump host. So you can use just one bare metal server to experience the whole deployment processes. For virtual machines, also need these two files. For host configuration, it's easier than bare metal because we don't need to specify the PMC information. For virtual machines, every power is controlled by a virtual commands, so we don't need that. For network configuration, it's similar. So it's similar to bare metal configurations. Now I will introduce OPNFV, CI, and CD. So for OPNFV, I just said this is an integration project. So the continuous integration and CD is very important for the for OPNFV project. So basically, the community OPNFV community provides the infrastructure in this green boxes. It provides the Jenkins masters. So if you want to run your own daily tasks or verification tasks, you need to register a Jenkins slave and connect it to the connected to the OPNFV community. So you can run your own test cases in your own lab. I'm proud of say this. This is your own lab. This is the interface server or the Jenkins slave, or you can say jump host connected to the community. So you set up your own projects or daily jobs using the Regal project. So Regal project set up Jenkins jobs. So Jenkins jobs is triggered by the Jenkins masters. So the Jenkins masters will in the Jenkins job, so it will specify which node, which slave should run this specific task. So so all the tasks that are started running in your Jenkins in your own pod. So this can be virtual machine, or this can be bare metal servers. You can just configure it flexibly. Yeah, this is the CI/CD. Now I summarize some of our what have we done. So for Compass on ARM platforms, so current status is all major features are already supported on ARM platforms. We submit about 20 plus patches. All the patches are merged to make Compass 4NFV project to support ARM, to can deploy ARM bare metal servers smoothly. So for now, we can run the Compass core containers on jump host. So this means the jump server can be ARM, and the bare metal was deployment and the Kubernetes deployment. Currently, we support V1.7 Kubernetes. And also, we set up 2 daily CI/CD jobs on bare metal ARM pods. So another plan is first to support Kubernetes V1.9. This is the latest version, and also support deploying Ubuntu. So we are now only for ARM platform. We only enable the CentOS as the node operating system. We are planning to support Ubuntu as the also. And also refine our CI/CD tasks to increase to add more tasks to make the and to make more validations and add more validation tasks in the community and to specifically for ARM related tasks. Okay, so any problem, any questions?
So this project is initialized by Huawei, and what is the proper time we can install this on ARM server?
Yes, this is project Compass4NFV is initiated by Huawei. It's not okay. It's not running on ARM, so the code are already merged and the installation documents are already merged. You can just reference it as a ARM-based installation documents in this upstream repo.
Also use the upstream repo. We already can try this.
Yes, exactly.
So do you have any recommended ARM devices to deploy this?
ARM devices.
ARM server. Which ARM server do you test it to?
No. This is doesn't depend on ARM server. You can use just your ARM service. It's okay. So this is kind of high level software. So it's not very directly related. Just if you want to and or CentOS can run on that server, everything's okay.
So you said the Juju Mas already can deploy it on ARM platform, but it's very strictly constrained with Ubuntu distribution. But with this installer, it can deploy on any of the.
Yeah. So this is actually the Juju. Juju now latest Juju supports deploying OpenStack on ARM. This is already supported, but from Kubernetes on ARM is not fully supported. So you cannot use the Juju or you use the Jordan installer to set up to deploy the Kubernetes on ARM platforms now.